All right, guys, we're on the back side of notes, and we just learned our trig functions, okay? Sine, cosine, and tangent, and we also learned that an angle always follows the trig function. And we also learned that it's equal to a certain ratio of two sides of our right triangle, okay? We have to realize that our angle symbol, okay, that follows the trig function can be used as, instead of an angle symbol, can be used as another symbol, a Greek symbol, and that Greek symbol is called theta, right? Theta. And it literally looks like a zero with a little line through it, a little slash through it. I usually do mine like a little bit more cursively, like kind of like a cursive capital O. Okay. But you can draw it however you want. Okay. Some people just draw a zero and then put a line through the middle of it. And that is the symbol called theta, and it represents an angle measure. Okay, so instead of using the angle symbol, we can use the Greek symbol used for angle. Okay, remember that an angle always follows the trig function, okay, and can be represented by theta. X can represent an angle, okay, or any capital letter. Okay. All right, so in number 1, it says, given a diagram of a triangle, complete the following table. Okay, so we have to realize from the front side that sine theta is equal to, remember, sum old horse, okay, sum for sine, old for O, over horse, H for horse, okay? So it's your opposite side over your hypotenuse side, okay? Cosine, caught another horse, okay? Caught, C for cosine, equals, okay, your A, that's your another horse, hypotenuse, okay? And then taking oats away. So T for tangent equal to your O, which is your opposite, over your adjacent, okay? All right, so some old horse caught another horse, taking oats away. So katoa, okay? All right, so in this first row, it's what they're saying is that we want to read from angle A. Okay, so we're going to go ahead and put our theta symbol in there. That represents the angle measure, okay, of that angle. No, it's tricky. You'll catch on. It's not that bad once we get going. Okay, so since we're reading from this angle here, sometimes, like I said, I put my little stick person so that I could label my opposite side, my hypotenuse, and my adjacent side. Okay, and now I can go ahead and fill this in. Sine of theta, okay, so here's my theta, equals your opposite sine, which is 3, over my hypotenuse side, which is 5. And there's the ratio. Okay, cosine is your adjacent side, which we labeled 4, over your hypotenuse side, which we labeled 5. Our tangent of our angle theta, is equal to our opposite side of 3 over our adjacent side of 4. And now we have the 3 trig ratios, okay, when we read from angle A in this triangle. Now in the second column or row, they want us to read from angle B. So we're going to go back. We're going to go ahead and erase where theta is. We're going to erase where our stick person is. We're going to pack up and move them, okay, up to angle B, because now they want us to read from angle B in this second row. And there's 2 things you're going to notice that switch, okay? Because theta is now up here, your stick person is now up here. This is no longer your adjacent, it's your opposite side from the angle, okay? And this is no longer your opposite, this is your adjacent side. But you're going to see that your hypotenuse side stays exactly where it is, okay? All right, so now when we do sine of theta, or sine of angle B, it's your opposite side, which is now 4, over your hypotenuse side, which is still 5. Cosine of theta, cosine of our angle, is our equal to our adjacent side, which is now 3, over our hypotenuse side, which is 5. Tangent of theta is equal to your opposite side, which is 4, over your adjacent side, which is 3. Okay. And we'll talk about this relationship in a couple days, but those are equal, and these are equal. Okay. And we have these being what they call reciprocals of each other. All right. So down here it says describe the patterns you notice from the table. And so what we can say is that sine of A, okay, is equal to, that's this one, is equal to the cosine of B. Okay. We can also say that the sine of B, which is this one, is equal to the cosine of A. All right, and that we will talk about in a few days. They're actually known as co-functions, hence the co in front of sine, you get cosine. Okay. All right, coming down, it says steps to solve for a missing side. And that's the first thing we're going to learn how to do with trig is to solve for a side that's missing in our right triangle. We won't be able to use the Pythagorean theorem because we'll only be given one side. Pythagorean theorem, you have to have two sides and then you solve for the third. All right, so starting with our first direction, it says determine what angle you are reading from, put a stick figure by it. Okay. We label the side given, okay, and the side missing. Okay. I only label two of my sides at all times. Okay. Some people will label three, and I feel like that confuses you a little bit. All right. In number 3 here, it says determine which trig function to use. So based on what you labeled up here. So if you labeled A and O, you would pick tangent. If you labeled O and H, then you would pick sine. Okay? If you labeled A and H, then you would pick cosine. Okay? That's why I only label 2. It's a lot easier to pick your trig function. Okay? Once we have our trig function equations set up, okay, then we're going to go ahead and we are going to solve for x. And the trick is to put your left-hand side of your equation over 1 so that you can cross multiply because you'll have a fraction equal to a fraction. Okay. A couple other things you have to remember. Okay, you must always write out the complete decimal before you round it so you can see what the decimal is and then see that you rounded correctly. Okay, because remember, I can't collect your calculator. All right, and the very last thing, super duper important, it's in capitals. Your calculator, guys, must be in what they call degree mode. Okay, so on your calculator, if you take it and you turn it on, okay, and you're going to see a mode key right next to your second key. So you got your second key, and right next to it, okay, this button here is called mode. You're going to press it. And for most people, it's like the third or fourth one down, depending on what kind of calculator you have. There's 2 options. One is called radian and one is called degree. You want to make sure that the black box, okay, is around your degree and it's highlighted. All right. That means your degree mode is on and you want it to be on. Bad news is your calculator defaults to radians, meaning if your calculator is cleared or you replace your batteries or your calculator completely dies and you charge it because it doesn't take batteries, chances are it will reset to radian mode and you're going to have to go back in if you use trig and change it back to degree mode. Okay, your calculator can stay in degree mode. It does not affect any of your other math. Okay, but it has to be in degree mode when you are doing trig. Okay, so hopefully that makes sense. All right, so now that my calculator is in degree mode, okay, we're going to go ahead and find the length of side x to the nearest tenth. Okay, so take a look. We have right triangle. All right, notice that we don't have an altitude drawn to our hypotenuse. This is why this isn't pigs are awesome pets or pigs love low hurdles. Okay, notice we only have one side of 20 inches and not another side, okay, which is why we can't use a squared plus b squared equals c squared. However, you do have one side, one angle, trig every single time. Okay, so notice your 55-degree angle. This is where your little stick person is reading from. Okay, and according to what he sees, he knows that this 20 is his hypotenuse because it's across from the right angle, and the side of x is next to him, and so that's his adjacent side. And therefore, we're going to be using A and H. So if you think about some old horse caught another horse taking oats away, I always recommend writing down SOHCAHTOA when you're doing trig so that you can see that the only trig function that has an A and an H is cosine. And so now we write down the formula. All right, so we say cosine theta equals A over H. And I recommend writing the formula down every single time. That way, all you have to do is fill it in. So we keep cosine, cosine, all right? Theta comes out, and remember, theta stands for an angle, and the angle you have is the 55 degrees. Equal to sign stays, your adjacent side comes out, x goes in, and then our hypotenuse comes out, and 20 goes in. And so far, so good. All we're going to do is make this a proportion by putting this over 1. So we have a fraction equal to a fraction. And then we cross multiply. X times 1 is x equal to 20 times the cosine of 55 degrees. And be very careful that your 20 and your 55 do not switch positions, and that you don't write 55 cosine 20, because then you're going to be saying that because the 20 follows your cosine, that 20 is your angle, and it's not. So it has to stay in that order. Okay. I also recommend putting the 20 first and then times the cosine of 55, because that's the way I'm going to type it in, and therefore I won't need any parentheses around anything. Okay. If you put the 20 and the 55 next to each other, you might make a mistake, because you'll have to use the parentheses to close the 55. And I don't want you guys to make silly mistakes like that. So if you get in the habit of writing it the same way every single time, you'll stay out of trouble. All right. All we have to do is grab our calculator. Now that it's in degree mode, type in 20 times cosine. Okay. And the cosine is right above your 789 key in your calculator. Okay. Actually, it's right above the parentheses, right above the 8. All right. So 20 times cosine 55. Okay. If you write it like that, you do not have to close the parenthesis after 55, but it's up to you. Once you hit enter, you should end up with 11.471528 ... I don't care if you don't write out all the decimals, but you have to write down a bunch of them so that I can see your rounding, okay? Directions say in this one, say nearest tenth, which is the 4, but look next door, and you're going to go ahead and tell me that your answer is 11.5. All right, so that the length of this side right here that was labeled X is 11.5. Okay. All right, let's go ahead and try another one. In this next picture, remember, you're reading from the marked acute angle, okay? You're never reading from the 90. Your stick person will never stand at the 90. He can't. And the reason is, if he stands at the 90, your hypotenuse will become your opposite side, and that's not right. Okay? So now that he is standing there, across from him is this X side, which would be known as his opposite side, and 3 would be known as his adjacent side. Okay? We know where the hypotenuse is, but I told you guys that you'll have better luck with trig if you only label the 2 sides, the side that's given to you, which is the 3, which is our adjacent, and then the side you're looking for, which has the X on it, which in this one is our opposite. Okay? Because we already wrote down SOHCAHTOA, okay, you can see that O and A is what we labeled, and therefore that's TOA. All right, but remember, TOA actually stands for the tangent function, so we write down tangent. Remember, an angle always follows the trig function, so tangent theta equals opposite over adjacent. All right, now that the formula is written down, piece of cake, we just fill it in. All right, so we keep tangent, tangent. All right, theta comes out, and remember, theta represents an angle measurement, which is 65 degrees in this problem, equal to our opposite, which comes out, and our opposite is X, over our adjacent, okay, which we labeled as 3. Okay. All right. Remember, when you solve for a side, we're going to make it a proportion so that we have a fraction equal to a fraction, and then cross multiply. 1 times X is X, equal to 3 times the tangent of 65 degrees. Okay. Remember, the 3 and the 65 cannot change positions. Okay. And also remember that the side should come first, then the trig function of the angle. If you remember that, you'll stay out of some trouble when you type it in your calculator. Okay, so now grab your calculator, type in 3 times tangent 65 and hit enter, and you should end up with 6.43352 ... Again, I don't need to see all the decimals, but I need to see a few of them, all right? Depending on what you're rounding to. So in this case, nearest tenth is the first decimal. I need to see the second decimal so I can tell that you're rounding correctly. Remember, sometimes we make mistakes, Okay. And you never know if this answer is correct. Okay. So don't assume. All right. And so, if you had, accidentally typed in 4 times the tangent of 65 and you ended up with a different decimal you didn't show me and then you rounded it without showing me, okay, I can't tell that you rounded correctly, plus you'll lose a point for typing it in incorrectly, and so you'll lose 2 points now, and I don't want you to lose 2 points. Okay, so make sure that you always show the work I show. All right, kind of like Simon says, Mrs. Ham shows that same exact work, so do you. Okay, and it'll create better habits in your math as well. All right, we got one last one on this page, and we're going to go ahead and take a look. Okay? Notice our 62-degree angle up here. That's the acute angle our little stick person is standing from, okay? Or at, and when he looks across his triangle, he sees 10, and therefore that's opposite from him. Okay? He also sees the x, and it's across from the right angle, and so that's his hypotenuse. Okay? Taking a look at SOHCAHTOA, when we wrote it down, you can see that O and H are the two pieces that the sine function uses. And so now we'll write down our formula that says sine, always followed by an angle, which is theta, equal to our opposite over our hypotenuse. Okay? We're going to keep sine. Okay? But theta is our angle, and our angle is 62 degrees. And so we replace theta with 62 degrees. Okay? We keep the equal sign. We replace the opposite side with our 10, and we replace our hypotenuse side with x. Okay? When we solve for a side, we make it into a proportion so that we can cross multiply. And we get 10 equals x times the sine of 62 degrees. And you're going to notice a little something different in this one, in that we don't end up with x equals like we did in the last two when we cross multiplied. But that's not a big deal. You just have to realize that this x has to get by itself. And so it's stuck to the sine of 62 with multiplication. So we're going to do the opposite, which is divide by the sine of 62. Okay. And if we divide on one side, we have to divide on the other side. Okay? The sine of 62's on the right-hand side cancel each other out, leaving you with only x, okay, equals. And now we type it in. We type in 10, but you have to realize you're going to divide by sine 62, enter, and you should end up with 11.3257, ... Okay? Again, taking a look at directions, they said nearest tenth. We look next door, and we end up with x equals 11.3. Okay? Not every single trig problem is rounded to the nearest tenth, so always be sure to check your directions up at the top on what they want you to round to. I would say about 99% of the time you will end up with a decimal when you do trig and solve for sides. Okay, so they will have to give you some sort of rounding directions up at the top. All right, guys, I'll see you guys on the next page of notes.